Good morning. This is a new lesson. We're talking about a new thing here. We're talking about parallelograms today. Last section we talked about polygons in general. This time we're going to start talking specifically about parallelograms and quadrilaterals. Okay, so parallelogram fundamentals basically works like this. First thing we're going to do is take care of some definitions. So a quadrilateral is simply a polygon that has four sides. A parallelogram is a special quadrilateral in which the opposite sides are parallel to each other. The naming convention is this. This just means this is quadrilateral ABCD, and that's what this symbol out here means, is quadrilateral. Okay, the vertices, as you can see, they're point A, point B, point C, and point D. Opposite sides. Opposite sides in this case are going to be AB and DC and AD and BC. Okay? Opposite angles. You have angle A, angle C are opposite, angle B and angle D are opposite. Okay, pairs of consecutive angles. Okay, so you're going to have angle A and angle D, angle A and angle B, angle D and angle C and angle B. Okay. All right. And these are all naming conventions for parallelograms. This thing right here does not stand for quadrilateral. I was correcting myself. It's actually a symbol for a parallelogram. Okay, the diagonals are line segments that connect the opposite vertices. So one diagonal would be here, one diagonal would be here. So AC and DB are the diagonals, and that's how they look. Okay. All right, let's look at theorems. Here are some theorems about this. And once again, theorems are simply rules that you can use to simplify your work. Okay, so what we have here is the first theorem says that opposite sides of a parallelogram are congruent. So in other words, they have an equal length. So these two would have the same length, these two would have the same length, and they're marked as congruent in the proper way. Okay, consecutive angle pairs of a parallelogram are supplementary. So what this means is if you have two angles that are next to each other in the parallelogram, they will add up to 180. So if we have angle A here, angle A plus angle B will equal 180. Angle A and angle D will equal 180. Okay? All right. Opposite angles are congruent. Okay, so what this means is if the angles are opposite each other, they are the same. Now this is true just for parallelograms and any of that subset. That is not true of a quadrilateral in general. Quadrilaterals in general do not have this specific characteristic. Okay, diagonals of a parallelogram bisect each other. So if it's a parallelogram, if I draw these diagonals, they're going to cut each other into two equal pieces. That does not mean that the diagonals are the same. In other words, this piece may or may not be equal to this piece. The only time that those diagonals will be the same is if it is a rectangle. And since squares are rectangles, then their diagonals are also congruent. Okay, this one says that AD is parallel to what other line segment? So we're talking about this segment here. So which other segment in this parallelogram is it congruent to? This is example 1. Okay, so it's congruent to BC. Okay, once again, it's marked correctly because it has the line segment symbol above it, so we need to make sure we follow those conventions. Okay, then they say the length of AB, which is AB by itself, that means the length of this one is equal to the length of what other segment? Okay, so by definition, since this one's parallel and opposite, it's the same length. Okay, so DC is the correct answer here. If you said segment CD, that would also be correct. And since they specified segment, that's why it has the marking above it. Okay, they want us to name this parallelogram, so the easy name here is ABCD. You just name it for the vertices. Okay, once again, put the proper symbol in front of it so everybody knows what you're talking about. Okay, then they want you to name the vertices of parallelogram ABCD. So the vertices are simply, once again, A, B, C, and D. Okay, example 5, what we have here is name the angle that's opposite angle C. So when you find angle C, the one that's opposite it has to be angle A. All right, example 6. Okay, name the diagonal having a positive slope. So I have one diagonal going across here and one diagonal going across here. So what we're looking for is the one that goes up as it goes from left to right. So the only one that's going to be going up as it goes left to right is DB. Okay, and since it is a line segment, we're going to identify it as such. Okay, name two angles that are supplementary to angle C. So angle C is supplementary to the consecutive angle. So the first consecutive angle would be angle D. So these two would add up to 180. The other consecutive angle is going to be angle B. So those two would add up to 180. So this is what we have, angle B and angle D. All right, example 8. Let's take a look at here. Line segment AC, which is this diagonal going across here, bisects what other line segment? Okay, if you remember, what we were told was that one of the theorems said that the diagonals bisect each other. So the other diagonal here is segment DB. So that's the one that's bisected. Okay, example 9. They want us to draw parallelogram HJK and label the measure of angle K is equal to X and measure of angle J as 2X minus 2, and then they want us to find X. Okay? So what we do is we draw our parallelogram and we follow the naming convention, which means that GHJK. Okay? So we have to name it in the sequence that we're given. So don't just randomly put these out there. They go in a certain sequence. You can go either clockwise or counterclockwise, and you will get the same results. Okay, so they said to mark angle K equal to X and angle J equal to 2X minus 2. So this means that these two angles, because they're consecutive angles, have to add up to 180. So X plus 2X minus 2 equals 180. Combine like terms gives us 3x is equal to 180, and they also went ahead and subtracted the 2 from both, or added the positive 2 to both sides. So this gives us 3x equals 182. Divide by 3 gives us that we have 60.6 repeating is the value of x. Since that's all they ask us to find, that's it. Sometimes they will ask us to put it back in and find the angle measure, but they didn't do that this time. Okay, let's move on to example 10. In this case, they're telling us that angle BAD, which angle BAD is this big angle right here, is equal to 65 degrees, and that the length of DB, which is this diagonal right here, is equal to 12. Okay, so the first thing they want us to do is find the measure of angle 7 and the measure of angle 5. Okay, since this whole thing is 65 degrees, then this part right here is 30, then it's just 65 minus 30. It gives us that would do us for angle 7. What they're doing here is because these are parallel lines, this is a transversal, then they're doing the alternate interior angles, give us that the measure of angle 5 is equal to 30. Okay, they went with the simple one first. Okay, it doesn't matter which one you do first, you can solve it in either direction here. So to solve for angle 7, we're going to do this. Angle 7 plus 30 equals the measure of angle BAD, which is 65. So the measure of angle 7 equals to 65 minus 30, because what they did is they simply took the 65, substituted in here, and subtracted the 30 from both sides. So this gives us the measure of angle 7 equals 35 degrees. All right, example 11. Still have the same thing. This big angle up here is 65, and this is DB is 12. So they want us this time to find the measure of angle ADC. So ADC is this angle right here, this big angle. Okay, this big angle right here and this big angle up here actually add up to 180 degrees because they are consecutive angles. Okay, so that's where they came up with this. We're going to substitute the 65 in for the angle BAD. We're going to subtract the 65 from both sides, which gives us the measure of angle ADC is equal to 115 degrees. Okay. Example 12. Not sure what they're going to ask us this time, but once again, this big angle up here is 65, this diagonal is 12. I suspect it'd be something about the diagonals since they haven't said anything about that. Well, here we go. Measure of angle 6. Measure of angle 6 has to be the same as measure of angle 7 because measure of angle 5 is 30. So what we've got here is this thing right here is equal to these two added together. We already found that angle 5 was 30. So we're going to simply substitute the 30 in for that, which gives us 65 is equal to this plus 30. Subtract the 30 from both sides to give us the measure of angle 6. So 35 degrees is equal to the measure of angle 6. Okay. All right. Suspect this one being the last example is actually going to ask us something about the diagonals. So let's see what we got. They want us to find the length of EB. EB is this half of the diagonal. They told us this whole thing is 12. Since it's bisected at this point of intersection here, then this means that you can just take half of the 12, which is the length of DB, plug it in, so we have 1/2 of 12, so EB equals 6. Okay, that concludes this one about parallelogram fundamentals. Be sure if you have any questions that we get those addressed before we go any farther tomorrow. Okay, thank you very much. We'll see you later.